All right, and it'd be pretty informal, so just let me know if you have any questions. And the big thing here that Mr. Jans and I wanted to get at was the univariate data. So univariate data is your one variable stats. And if you look up here, you have socks. And I think Mr. Jans says socks. Is that correct? Okay, so when you have univariate data, meaning one variable data, you're looking at the shape, if there's any outliers, the center, oh, he's got it right up there, and then the spread. Okay, so this is kind of on that. You guys can all read, so I'll let you read this. I think it'd be more valuable if we just start working on the problems when I can give you feedback on it. Sound good? Yeah, okay. So I actually want to start on number one with the box plot. I think that is probably the most helpful out of all of these when it comes to describing a distribution. So let's go there. And then I want to go to number one on that one. Those are the two I really want to get through. And if I'm going too slow, just let me know and we can kind of cruise faster through it. And yeah, okay. So number one, it says, as part of the United States Department of Agriculture super dump cleanup efforts in the early 1990s, various sites in the country were targeted for cleanup. 3 of the targeted sites, River X, River Y, and River Z, had become contaminated with pesticides because they were located near abandoned pesticide dump sites. Measurements of the concentration of aldrin, a commonly used pesticide, were taken at 20 randomly selected locations in each river near the dump. Circle the word 20, okay? The box plots display the 5 number summaries for their concentrations in parts per million of aldrin for the 20 locations that were sampled in each of the 3 rivers. Iqrs has compared the distributions of concentrations of aldrin among the 3 rivers. Now, the first thing you need to know is SOX, you can't just put S colon U or O colon C colon S colon. That's not okay. They are expecting complete sentences. There is not enough room, in my opinion, for this. So I'm gonna start over here and do part A. Now, just like you write an outline in English, whenever you see the word describe or something about comparing the distribution, go ahead and write SOX as just a little outline for yourself. When you're comparing univariate data, you do have to address those 4 things: the shape, the outliers, the center, the spread. And now the big thing is this word compare. The AP readers are going to be looking for comparison words. So they're going to be looking for words like least, greatest, smaller, bigger, words like that. Okay? Questions there? All right, so let's start with the shape. How would you compare the shapes of river X, Y, and Z? Would you say river X is symmetric or skewed? Do you have any questions about that? If you said it was skewed, why would you say it's skewed? Yeah, I would say if anything that this is maybe slightly skewed, right? It doesn't have a huge tail here. But if you're gonna like imagine it as a histogram, maybe like 4 bars, you could maybe say, or I'm sorry, I'll spread it out. You could maybe say it's skewed right, slightly skewed right. That's what I would say. So I would say river X is slightly skewed right. How would you describe river Y? I think I mean, again, you're looking at if you can fold it in half and it's going to match up, and the half is at the median mark. So if you'd fold it right here, you can notice that this part's really going to overlap, right? So that's how I know it's skewed on the right-hand side here. If I folded it here, is it going to match up? Close. Is it close enough? Yeah, the hard thing about it, especially for some of you calc kids, it's not like necessarily right or wrong, okay? Usually I'd say the AP does a pretty good job of it's going to be one or the other. This one I could see arguments both ways. How about this one though? I would say this one is pretty what? Which way is this going to go? If you'd fold it in half, which side's going to overlap? Yeah, the left side. I'd say this is pretty skewed left. Or not pretty, but for the most part, it's skewed left. So river X and Z are slightly skewed. X is skewed right. And Z is skewed left. where y is more symmetric. Are there any outliers? How do you know an outlier in a dot plot? Or, I'm sorry, in a box plot? That would be a dot, yeah. No outliers for any of the distributions. The center, when you are given a box plot, use the median, and the spread when you're given a box plot is the IQR. Now, this is a side note, like a grocery list kind of deal. You do need to know that if you have a symmetric distribution, typically we always use the mean and the standard deviation as center and spread. If you have a skewed distribution, we use the median and the IQR as a measure of center and spread. Okay, so that's a little side note. But overall, we're given a box plot here, so we're just going to use the median and the IQR for all of them. I would say the median here is approximately what for river X? Would you say it's approximately 5? Or maybe 5.25, could we say? Okay, approximately 5.25. Right here, what would we say? Yeah, I'd say that's about 5. And the median here, what's that about? 4.5, sure. Okay, this is where we have to use comparison words. So we could say river X is larger than river Y and Z. River Y is in between, okay, is approximately 5, which is in between the median for river X and Z, and river Z is the smallest median, or has the smallest median of all of them. Okay, does that make sense using those comparison words? Yes or no? Okay, all right, so let's write a quick sentence on that now. It doesn't matter exactly how that sentence is written as long as you do use those comparison words. Okay, so we have river X is median is approximately, and you can put capital M is 5.25, is the largest, followed by, we're using the median, okay? The bar is always the median, followed by river Y, which is approximately 5, and the smallest is river Z. The median is approximately 4.5. And then we have to look at our IQRs. And again, I probably could, I'm doing this like off the fly, right? So I could, if I thought about it, I could maybe, my English skills, I need to think about it a little bit faster. I'm not good at English off the fly, like just writing a really good sentence off the fly. So forgive me, I could probably, if I thought about it a little longer, I could make it a little more precise, and that's okay. Okay, next, let's talk about the IQRs. IQR, what is IQR as a review? Interquartile range, which is quartile 3 minus quartile 1. Okay, so quartile 3 here is approximately, let's say 7.5. Should we say approximately 5? Yeah. So our interquartile range here is going to be 7.5 minus 5, so that gives us approximately 2.5. Okay. Our IQR here looks like we can say that's about 6. That's about 4, so the IQR is about 2. And then here, what would you say, about 4.5 and about 3.5? So that IQR is about what? 1, yeah. Are you okay if I don't write the third sentence and you just know that you need to state, now for the spread, river X has the largest interquartile range, followed by river Y, which is interquartile range is approximately 2. The smallest IQR is river Z, okay? Questions there? So what is the final takeaway from all of this? We're looking at SOX, we're comparing the quantitative part of it, saying smaller than, greater than, using some sort of comparison word. Okay, let's go on to part B. 20 of the concentrations of aldrin for river X are given below. Construct a stem plot that displays the concentrations for the river X. Do we remember how to make a stem plot? Sound effect. That's okay. Do you guys remember how to make a stem plot? Someone say yes or no. Someone give you something here. Okay. Look at your minimum. Look at your maximum. It looks like my minimum is 3.4. It looks like my maximum, I'm seeing 8.7. Does anyone see anything higher? No one sees anything higher? Okay, so we have 3.4 and 8.7. How do I make a stem plot? I take my index fingers, I cover up the last digit, and those are my stems. And then I have my leaves, back to like middle school, right? Stem and leaf. I'm going to start with 3. I go all the way to 8. I do need a key or you will be docked. So just take your minimum number, 3.4 is equal to 3 or line 4. Let me know if I'm going too fast. I'm trying to get through a lot here as well. So, okay, now the biggest mistake that people will make will be with the leaves. You need them to go in increasing order. Okay, so I want to look at all my 3s. I have 3.4. Do I have any other 3s? 3.7, where? Oh, right here. Is that it? Okay, 4, 7. Cross them off, guys, as you're doing just a strategy for your test taking, so you know you used it already. Next, I see 4.0, 4.2, 4.3, and hopefully they'll put it in order for you, and it looks like they did, right? Oh, no, they didn't. There's a 6 there. Shoot. Where's the other 6? Oh, yep. Okay. Okay, so here's another big deal, guys. If you're going to describe this distribution, you really want to make sure these are all in nice columns. So 4.0, done. 4.2 is going to go right below the 7. 4.3, 4.6, 6, and then 7, 8. 5s. I don't know, but it can affect how you describe it because you can look at a histogram and describe the shape. So I don't know. I really don't know that answer to that question. I can look at it and let you know tomorrow though. Okay, 5.6 I have, 5.5, 5.3, 5.1, 5.3. So I'm going 1, 2, 3s, right? Do you want me to keep going or are you feeling okay about it? And we can move on. Do you want to finish it just because you're the type of people you want the problem done? Okay, so let's finish it. 3, 3, 5, and then, did I forget one, you guys? Or did I just not cross it off? Okay, what do I need left here? 5 and 6, and that's it? Okay, thank you. Okay, do we have any 6s? No, do we have 7s? Yes, do we have just 1? 3 and 5? Okay, perfect. And then 8s, we have 0, 6, and 7. No, 0, 2, 6, 7. Are we good? All right, any questions there on the stem and leaf plot? All right, part C says describe the characteristics of the distribution of aldrin concentrations on river X that can be seen in the stem plot, but that cannot be seen in the box plot. So what's an advantage of a stem plot versus a box plot? What do we see? There's a couple things there. Okay, so we see, this is all for river X, right? What information does this stem plot give us that the box plot does not give us? Yeah, the individual values. What else can we see here? other than the individual values. There's one other thing. We can see the distribution a little bit more. And if you look at it now, I still think it looks pretty symmetric. Would you say that? No, you think it's skewed? Okay, that part doesn't matter. But what else does it? Because right now the question is just what can we see? What else can you see? There's one more thing you should be able to see. There's a what? There's a gap right here. Do you see that there's nothing in the sixes? We can't see that up here. Okay, we don't see that there's a gap. The gap is part of like the anything unusual or anything unexpected. Okay, those aren't outliers. We know they're not outliers, but we know there's a gap. And when there's a gap, you should comment on that when you're describing the distribution. So I'm not going to write it down, but you can take a second here. So for part D, what you're going to want to write down is you see the individual values, which can be helpful. You also see that there is a gap between 6.6, okay, this last one here. I'm sorry, 5.6, excuse me. 5.6, you see there's a gap. There's nothing in the sixes, and then our next value is 7.3. How are we doing? Is there anything you need from me? Like you'd rather try one on your own and then me check it? It does not matter to me. Keep walking through it. All right. Again, if you're feeling like this is, I got this, I don't need me walking you through it, go ahead and just try it on your own and then I can check it for you before you leave. I want to go to number 1 on the first page where you see the lead levels. Okay, so number 1 has a distribution here of a stem and leaf plot or a stem plot. One thing I want you to notice right away, so this is just like a side note, is what do you notice about those stems? There's repeats, right? Do you remember what that's called when it's repeats? These are split stems. I'm not certain there'd be like a question on split stems, but it's good to be aware of what a split stem means. A split stem means instead of going by like tens, what we just did, so all of our second digit was like from 0 to 9, we're actually going by fives here. So you can notice here I have 3 to 0. So in this row, the leaves would all be numbers 0 through 4. And then this row, it's all the leaves are 5 to 9. So in this first 4 are all the leaves that are 0 to 4 again, and then 5 to 9. Does that make sense to you? Like give me a nod or something so I know that makes sense. Okay, so the split stems are when your stems are, or when your leaves are going by fives. Okay, the first row is 0 to 4. The second row is 5 to 9. And what would be an advantage of that? An advantage would just be that you can see the distribution a little bit more. It's a little more spread out so you can really see what's going on versus what we did here where it's all, it's chunked together a little bit more. Okay, questions there? All right, I like this problem because it does have a test in it, so we're going to go through that. First of all, it's just a pretty quick part A, just a quick, simple question. The number 1 question is usually something about describing a distribution, something about univariate data. It shouldn't be too difficult. I was a little surprised to see part B in number 1 because usually a confidence interval or test is part of like 3 or 4, sometimes 5. But that's all right, that does happen. But part A specifically should hopefully feel comfortable for you. What proportion of crows in this sample had lead levels that are classified by the biologist as unhealthy? And if you read through the problem, you see you have a random sample of 23 crows, and levels greater than 6.0 is considered unhealthy. So all I need to do here is I need to be able to read the stem plot. That's what this part is getting at. Do you know how to read a stem plot? And you can read the stem plot and say, okay, yep, I know what the key means. This right here is 6.3, 6.4, 6.6, and 6.8. So all 4 of these levels are deemed unhealthy. So in this problem, you're literally just taking 4 divided by 23. And that's the answer. Those are deemed unhealthy. Okay. Questions there? All right, the next one, B, it says the mean lead level of the 23 crows in the sample was 4.9 and the standard deviation was 1.12. Construct and interpret a 95% confidence interval for the mean lead level of crows in this region. Do you have room on the back? No, you don't. You might want to grab a sheet of paper out here, unless you write really small. I just don't think that there's enough room, but it's up to you. So kind of depending on how you know your writing, if you're typically a large writer, otherwise plan to write small here. For the state plan, do conclude you use those all for intervals and tests. I think Mr. Jans and I differ a little bit how we do the states. Does he have you just restate the problem for an interval? I believe he does that. If you don't remember, I'm fine if you just, hey, look, it's up here, but I do expect my kids to label what you're looking for. Okay, so today in class, I was talking about when we choose a test, we need to say, how many samples do we have? Okay, so how many samples do we have right here? Do we have one sample or two samples? We have one sample. We have to decide if we're using a T or a Z. How do I know if it's a T or a Z? I'm not sure if Mr. Jans has taught you this. I have an acronym. ZAP, TAX. Z is always for proportions, percents, decimals, so on, fractions. T is always for quantitative data, where you get your averages, okay? So right away here, I see that I have an average, right? I know I'm gonna be using a T distribution. I have a one sample, T, they want an interval for mu. So I liken my kids in the state part to tell me what is mu. Mu is equal to the true, right here. Use the sentence to help you answer these questions. The true mean lead level of all crows in this region, I think. Okay, questions there. I want to know what this is. We don't know what it is. We only know what the average is for 23. So I want to take that statistic and build an interval so I can have 95% confidence that it's somewhere in there. Okay, the next part's your plan. Do you remember the acronym for the plan for your conditions? Yeah, we're not running, we're rinning. What does R stand for? Yeah, random, stated random. It is stated random above, and you can see that way up there. A random sample of 23. Independence. What is the independence condition? Yeah, the 10% rule. So I'm taking 10 times my sample size 23 is less than the population. And what's the population? What are we dealing with? Yeah, all crows. Yeah, all crows in the region. My normal condition is the one where people get mixed up the most. Okay, let me rewind really quick. A multiple choice problem I feel confident that you might get would be about the independence condition. The independence condition allows you to use what in your test or your interval? The standard deviation. When this has been met, that says yes, you can go ahead and use that standard deviation, that measure of spread for the distribution. Your normal condition allows you to use your tables to get that p-value or to build that interval. Okay, now people mess up on this a lot. It's either going to be n is greater than 30 or n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Which one is it going to be? It's going to be the first one. N is greater than or equal to 30. Well, our n is 23, which is not greater than or equal to 30. I talked about this in my class today, but 30, where does that number 30 come from? You need to know that for the test. The central limit theorem. That would be something on the side that you want to write down as like a grocery list reminder, okay? The 30, n is greater than 30, that comes from the central limit theorem. After it's 30, doesn't matter. We can just go ahead and proceed. But if it's less than 30, we have to actually show a plot now. I told my kids the fastest plot to show is a dot plot. Don't take the time to enter it in your calculator. You can quickly just say, oh, it goes from 23 to 30, 23, 24, 25, all the way to 30, and quick make some dots. And you need to show that there's no strong skew and no outliers. If it's a really small sample, it needs to be pretty symmetric, okay? If it's a really small sample, it needs to be pretty symmetric. 23 is almost at 30, so we're okay. There can be some skew. And what's nice is we don't actually have to plot this. Why do we not have to plot this? There's a stem and leaf plot above, okay? So we just state the plot above is symmetric enough. And I'm sorry for some of you who know this, I'm trying to give some background information, things to remember as well for the AP test that you might see some more. So if you're snoozing because you're just like, okay, come on, get to the point, forgive me. Okay, the method. What's our method? How many samples? Yeah, one sample. T or Z? T, interval or test? Interval. 4 mu. And we already defined mu. The do part. In your confidence, or in your, I'm sorry, in your formula sheet, the confidence interval is right there. It's on page, it's coming, page 5, okay? And you have your standard deviations here as well, all right? So we have our statistic X bar, plus or minus our critical value. We're dealing with a T distribution, so it's going to be T star times the standard deviation. So it shows you all of that, but it says it in general terms. It doesn't tell you what exact statistic you're dealing with. So you have to just think about that there. Okay, our T star times our standard deviation. Look at your chart. What does your standard deviation say for one sample? You're using your standard deviation divided by the square root of n. Your T star needs a degrees of freedom with it. Your degrees of freedom, do you remember what that one is? Yeah, n minus 1. So we're going to do 23 minus 1, which is 22. So a reminder on your chart. Again, if I'm going too fast, I apologize. I'm just trying to get through a lot here. On your chart, you want to go to where it says confidence level on the T values. Okay, I want 95% confident. I find my degrees of freedom at 22. And I get, is it 2.074?
Yes.
Okay, 2.074. Does anyone need help reading that chart? Okay, take that standard deviation they give you, 1.12, divide it by the square root of 23, plus or minus the standard deviation they give you, and you calculate it right there. Did anyone go ahead and plug it in? Do you have it yet? 2 point. Thank you. Thank you very much. Okay, now here's a big thing you want to notice on the free response, you guys. If it just says construct an interval, you're done. You don't have to interpret it. But if it interprets it, you need to keep going to the conclude part. I am 95% confident that the interval from 2.577 to 7.22 includes the true mean lead level of crows in the region. Again, use the sentence to help you with the context. I am 95% confident that the interval from 2.577 to 7.22 includes or contains the true mean lead level of crows in this region. Okay, that's a great question. When is it when the zeros in the interval? You can predict that might be a question, either multiple choice or free response. That's a big deal. If zeros in the interval, what are we dealing with? If we have an interval that looks like this, zeros in the interval, right? Well, you can apply it to a hypothesis, but because zeros in the interval, what you're dealing with here is you're dealing with, like for this one, we're dealing with mu's. And you did a 2-sample t interval for mu1 minus mu2. And what that means is now there is a chance that there's no difference between the two. So if you had a null hypothesis and an alternative hypothesis, you would have no evidence for that HA. Right now, there's a chance that it still would be equal. Does that make sense to you? Okay, I need to find a problem then to put it in context with. Okay. Now, one question that might be a follow-up question, if I asked you and I said, hey, what did they say the standard was? If it's over 6, they're not happy, right? So if I'm a scientist right now and I get this interval from a statistician and I see the interval and I could predict this could be a follow-up question, they might say something like, are the scientists okay with this level, 2.577 to 7.22? That's the true average. Are scientists okay with this interval? What would you say? No. Why not? It contains 6. So as a result, it contains 6 or higher. There's a chance that on average, these crows that's like an unhealthy, those lead levels are unhealthy. So what would we want? We'd want an interval where the highest point is what? Is below 6, right? We'd want it to be below 6, 5.99 even, but we want it below 6. All right, let's look over I think he has a couple more questions. Does anyone see anything that's kind of like startling at you that you want to, let's talk about number 30 quickly. It's a multiple choice one. And again, I apologize. I don't always teach this fast. I'm just trying to get through a lot of information. Okay, number 30. For which of the following distributions is the mean greater than the median? What do you remember about the mean and the median versus like symmetric or skewed distributions? Close. You're right with something chasing something. The mean chases the tail. Okay, the mean chases the tail. So with a symmetric distribution, the mean is going to be approximately equal to the median. Okay, with a skewed left, that's going to look like this, right? The mean is going to be less than the median. With it skewed right, the mean is greater than the median. So which distribution here is skewed right? Yeah, A is skewed right. Okay. B is symmetric, so they're going to be equal. C is symmetric, they're going to be equal. D is symmetric, they're going to be equal. And E is skewed left. Wherever the tail is, that's the side that the skew is. Questions? All right, let's do another multiple choice one because those can go quick. What is it? I dropped mine. Number 10, the box plots above summarize true data sets A and B. Which of the following must be true? Set A contains more data than set B. The box of set A contains more data than the box of set B. The data in set A have a larger range than the data in set B. What do you think? What did you say? Why B? Yeah, you don't know how much data is in your box plot. I've seen these kind of problems over and over again. You only know the percentiles of these, okay? You don't know how much data. So that's why the answer is B, or the truth is Roman numeral 3. Are there questions there? So the range is the largest range. Set A, if you would do the max minus the min here, that's going to be bigger than here. Do you have a question? No. Okay. Don't be scared because I'm taping. Okay. All right, I'm going to stop taping now, and if anyone wants to stay after for about 10 more minutes just to like go through anything else, I can do that. Thank you guys for coming. Thank you, Eric, from my class for coming. Get a shout out on the video. And let me know if there's anything else that you guys need.